Hard-drawn copper is copper that has undergone a cold working process called drawing. This process involves pulling the copper through a die to reduce its diameter and increase its tensile strength. The drawing process makes the copper significantly harder and stronger than annealed copper, which is copper that has been heated and cooled to soften it. The increased strength of hard-drawn copper is a key property that makes it suitable for specific electrical applications. Yes, hard-drawn copper is generally available for purchase at local electrical supply houses. You can typically order a spool of hard-drawn copper in various sizes. These sizes commonly range from 10 American wire gauge to 1000 kc mil, providing a wide range of options for different electrical needs. Hard-drawn copper is frequently used for overhead service drops due to several important characteristics. Firstly, high tensile strength is one of them. This allows it to withstand the stresses and strains associated with being suspended overhead, including wind, ice, and its own weight. Secondly is corrosion resistance. Copper is naturally resistant to corrosion, which makes it well suited for outdoor applications where exposure to the elements is unavoidable. Thirdly, flexibility. Despite its increased strength, hard-drawn copper maintains enough flexibility to be bent and routed during installation, allowing it to be worked with relatively easily. Section 230.23b of the National Electrical Code addresses the minimum size of service conductors. The general rule specifies a minimum conductor size of 8 American wire gauge. However, there is an exception that allows for the use of 12 American wire gauge hard-drawn copper or equivalent for conductors that supply only limited loads of a single branch circuit. This applies to situations such as small polyphase power, controlled water heaters, and similar loads where the current demand is relatively low. This exception is based on the understanding that these smaller loads generally require less current and have a reduced potential for voltage drop compared to larger loads. Therefore, the use of a smaller conductor like 12 American wire gauge hard-drawn copper is acceptable in these specific cases. Hard-drawn copper strength is directly related to the cold working process it undergoes. During drawing, the copper's crystalline structure is altered, resulting in grain elongation and increased dislocation density. These changes within the material's microstructure impede the movement of atoms, making the copper harder and more resistant to deformation. This is why hard-drawn copper has a higher tensile strength compared to annealed copper, which has a more relaxed and less stressed crystalline structure. The choice between hard-drawn and annealed copper depends on the specific application. Annealed copper is preferred when flexibility and ductility are paramount, such as in applications requiring frequent bending or shaping. Hard-drawn copper is favored when strength and resistance to deformation are more critical, such as in overhead conductors or applications where the conductor is subject to mechanical stress. The equivalent materials mentioned in the exception for section 230.23b refer to other conductors that possess similar or superior mechanical and electrical properties to 12 American wire gauge hard-drawn copper. These equivalent materials might include other copper alloys or even aluminum conductors that meet the necessary requirements for ampacity, tensile strength, and corrosion resistance. When selecting an equivalent material, it's essential to ensure that it complies with all applicable codes and standards and that it is suitable for the intended application. Factors to consider include the conductor's ampacity rating, its ability to withstand environmental conditions, and its compatibility with the termination methods used in the electrical system. The process of drawing copper to increase its strength involves specialized equipment and precise control of the drawing parameters. The copper rod or wire is pulled through a series of progressively smaller dies, each reducing the diameter and increasing the tensile strength. The drawing speed, die angle, and lubrication are carefully controlled to ensure that the copper is uniformly deformed and that the desired mechanical properties are achieved. Multiple passes through the dies may be necessary to achieve the final desired diameter and strength. The quality of the hard-drawn copper depends on the purity of the copper used as the starting material. High-purity copper, typically greater than 99.9% copper, is essential to ensure that the resulting hard-drawn copper has excellent electrical conductivity and corrosion resistance. Impurities can reduce the conductivity and weaken the material, making it less suitable for electrical applications. Therefore, manufacturers of hard-drawn copper carefully select and process the copper to meet stringent quality standards. The size range of hard-drawn copper available from 10 American wire gauge to 1000 kc mil covers a wide spectrum of applications. Smaller gauges, such as 10 American wire gauge and 8 American wire gauge, are commonly used for branch circuits and control wiring. Larger sizes, such as 500 kc mil and 1000 kc mil, are used for feeders and service entrance conductors in commercial and industrial buildings. The selection of the appropriate conductor size depends on the ampacity requirements of the circuit and the allowable voltage drop. The National Electrical Code provides tables and guidelines for determining the correct conductor size for various applications. In addition to its use in overhead service drops, hard-drawn copper is also used in other applications where high strength and corrosion resistance are required. These applications include grounding conductors, equipment grounding conductors, and certain types of underground cables. In these applications, the hard-drawn copper provides a reliable and durable connection that can withstand mechanical stress and environmental conditions. When working with hard-drawn copper, it's important to use the correct tools and techniques to avoid damaging the conductor. Improper handling can cause nicks, scratches, or kinks in the copper, which can reduce its strength and increase the risk of failure. It's also important to use the correct connectors and terminals to ensure a secure and reliable electrical connection. Copper is a versatile and widely used material in electrical applications due to its excellent conductivity, corrosion resistance, and workability. However, the properties of copper can be modified through various processes, such as annealing and drawing, to tailor it to specific applications. Understanding the differences between annealed and hard-drawn copper is essential for selecting the correct material for a given electrical installation. The National Electrical Code, or NEC, provides comprehensive guidelines for the safe and effective installation of electrical systems. It covers a wide range of topics, including conductor sizing, overcurrent protection, grounding, and wiring methods. Adhering to the NEC is essential to ensure the safety of people and property and to prevent electrical hazards. Electrical inspectors are responsible for enforcing the NEC and ensuring that electrical installations comply with the code requirements. They review plans, conduct inspections, and issue permits to ensure that electrical work is performed safely and correctly. Working with a qualified and licensed electrical contractor is essential to ensure that electrical work is performed in accordance with the NEC and local codes. A qualified contractor has the knowledge, experience, and training to perform electrical work safely and effectively. They can also provide guidance on selecting the correct materials and equipment for a given application. When installing overhead service drops, it's important to follow the NEC requirements for clearance from buildings, ground, and other objects. The NEC specifies minimum clearance distances to prevent electrical hazards and to ensure the safety of people and property. It's also important to use the correct hardware and supports to properly secure the service drop conductors and to prevent sagging or damage. Maintaining electrical systems is essential to ensure their continued safe and reliable operation. Regular inspections, testing, and maintenance can help to identify and correct potential problems before they lead to failures or hazards. It's also important to keep electrical equipment clean and free of debris to prevent overheating and corrosion. When making electrical repairs or modifications, it's important to de-energize the circuit and to follow lockout-tagout procedures to prevent accidental energization. Lockout-tagout involves disconnecting the power source and placing a lock and tag on the disconnect switch to indicate that the circuit is being worked on. This helps to prevent electrical shock and other hazards. Copper has a high electrical conductivity, second only to silver among common metals. This means that copper allows electrical current to flow through it with minimal resistance. This high conductivity makes copper an ideal material for electrical wiring and conductors. The electrical conductivity of copper is affected by temperature. As the temperature of copper increases, its electrical conductivity decreases. This is because the increased thermal energy causes the electrons in the copper to move more randomly, which interferes with the flow of electrical current. The temperature coefficient of resistance for copper is a measure of how much its resistance changes with temperature. The corrosion resistance of copper is due to the formation of a thin layer of copper oxide on its surface. This oxide layer is tightly adherent and protects the underlying copper from further corrosion. The corrosion resistance of copper is affected by the environment. Copper is more susceptible to corrosion in the presence of certain chemicals, such as acids and ammonia. Copper is a ductile material, which means that it can be easily drawn into wires or shaped into other forms without breaking. This ductility makes copper an ideal material for electrical wiring, as it can be easily bent and routed around obstacles. Copper is also a malleable material, which means that it can be easily hammered or rolled into thin sheets without cracking. This malleability makes copper a useful material for a variety of applications, such as roofing and flashing. The melting point of copper is 1085 degrees Celsius or 1985 degrees Fahrenheit. This high melting point makes copper a suitable material for high-temperature applications, such as electrical heating elements. Copper is a good conductor of heat, which means that it can quickly transfer heat away from a heat source. This thermal conductivity makes copper a useful material for heat sinks and heat exchangers. The thermal conductivity of copper is affected by temperature. As the temperature of copper increases, its thermal conductivity decreases. Copper is a recyclable material, which means that it can be melted down and reused without losing its properties. Recycling copper conserves natural resources and reduces energy consumption. The price of copper can fluctuate significantly depending on market conditions. Factors that can affect the price of copper include supply and demand, economic growth, and geopolitical events. Copper is a strategic metal, which means that it is essential for a country's economic and military security. Many countries maintain stockpiles of copper to ensure a reliable supply in times of crisis. Copper is used in a wide variety of applications, including electrical wiring, plumbing, roofing, and industrial machinery. Its versatility and desirable properties make it an essential material in modern society. Hard-drawn copper wire is commonly used in electrical transmission lines due to its high tensile strength and conductivity. The strength allows it to span long distances between support towers, and the conductivity ensures efficient power transmission. In overhead power lines, hard-drawn copper is often used in conjunction with steel reinforcement to provide even greater strength and support. The steel core carries the mechanical load, while the copper provides the electrical conductivity. Copper alloys, such as brass and bronze, are also used in electrical applications. Brass is an alloy of copper and zinc, and it has good corrosion resistance and machinability. Bronze is an alloy of copper and tin, and it has high strength and wear resistance. Copper is used in electric motors and generators to create the magnetic fields that drive these devices. The copper windings in a motor or generator carry the electrical current that produces the magnetic field. In transformers, copper is used in the primary and secondary windings to transfer electrical energy from one circuit to another. The copper windings are carefully designed to provide efficient energy transfer and minimize losses. Copper is used in printed circuit boards, or PCBs, to create the conductive pathways that connect electronic components. The copper traces on the PCB carry electrical signals between the components. Copper is used in semiconductor devices, such as transistors and integrated circuits, to provide electrical connections and heat dissipation. The copper interconnects in these devices are critical for their performance and reliability. Copper is used in solar panels to collect and transport the electrical current generated by the photovoltaic cells. The copper grid on the surface of the solar panel collects the current, and the copper wiring transports it to the inverter. Copper is used in wind turbines to generate electricity from wind power. The copper windings in the turbine's generator convert the mechanical energy of the rotating blades into electrical energy. Copper is used in batteries to store electrical energy. The copper electrodes in the battery facilitate the flow of electrons during charging and discharging. Copper is used in electric vehicles, or EVs, in a variety of components, including the motor, battery, and wiring. The high conductivity and durability of copper make it an ideal material for these demanding applications. Copper is used in data cables such as Ethernet cables to transmit digital information. The copper wires in the cable carry the electrical signals that represent the data. Copper is used in coaxial cables to transmit radio frequency signals. The copper center conductor and shield provide a low-loss pathway for the signals. Copper is used in audio cables to transmit analog audio signals. The copper wires in the cable carry the electrical signals that represent the sound. Copper is used in musical instruments such as guitars and pianos to create the sound. The copper strings in these instruments vibrate to produce the musical notes. Copper is used in jewelry due to its attractive color and malleability. It is often alloyed with other metals to create different colors and properties. Copper is used in plumbing pipes and fittings due to its corrosion resistance and durability. The copper pipes carry water and other fluids throughout buildings. Copper is used in roofing and flashing due to its corrosion resistance and weather tightness. The copper sheets protect buildings from the elements. Copper is used in cookware due to its excellent heat conductivity. The copper pans and pots distribute heat evenly, preventing hot spots. Copper is used in art and sculpture due to its malleability and attractive color. It can be easily shaped into various forms and designs. Copper is an essential element for human health. It plays a role in various bodily functions including energy production, iron metabolism, and nerve function. Copper deficiency can lead to various health problems such as anemia and neurological disorders. The recommended daily intake of copper for adults is 0.9 milligrams. Copper can be obtained from a variety of foods including liver, shellfish, nuts, seeds, and whole grains. Copper is an antimicrobial agent, which means that it can kill or inhibit the growth of microorganisms. Copper surfaces can help to reduce the spread of infections. Copper is a sustainable material due to its recyclability and durability. Recycling copper conserves natural resources and reduces energy consumption. Using copper in durable products reduces the need for replacement and minimizes waste. Copper is a valuable and versatile material that plays a vital role in many aspects of modern life. Its unique properties make it an essential material for a wide range of applications.